In this further maths video, we'll be looking at stem plots. A stem plot is a way of ordering and displaying a set of data. It's suitable for smaller sets of data up to about 50, and the main reason for that is all the raw data is kept. Here's an example of how it works. We've got a set of data here. Basically the stem represents the tens and the leaf represents the ones. So this 02 represents the number 2, 04 represents the number 4, and so on. What you'll notice is all the numbers are in order, so 2, 4, 5, 7, 10, 16, 16, 18, etc. One number I have left out is this 32, so I just want to show you how I would put that onto a stem plot. So 32 has the tens of 3 and a leaf of 2, so it would go here beside the 0. Okay. It's really important that in a stem plot we include a key. So here's my key here, and it shows that 1 with a line, 0 represents the number 10. If I didn't have that key there, 1/0 could actually represent 1.0, and this could be 2.1 and so on. So it's important that we have a key there so we're not mixed up with what the numbers we're looking at actually are. Final thing I want to look at with stem plots is sometimes when the data is really close together, it's tricky to draw a stem plot. So if you notice in this second example here, all of my numbers are between 0 and 8. So if I organise it into a stem plot the same as I did in the first one, I get a stem plot with all of the numbers are in the same row, okay, which is not really that useful. It doesn't tell me anything about the distribution of the data. All it really does is put the numbers in order. Okay. Another way of organising it is to split the stem in halves. So in this second example here, I have got the first stem represents, will have in it all of the leaves from 0 to 4, and the second stem will have all of the leaves in it from 5 to 9. Okay. So again, this time it tells us a little bit more information. It's not just putting the numbers in order. Now we can actually see that there are more numbers in the top stem than there are in the second stem, meaning that most of the numbers were between 0 and 4, and there are only a few numbers there between 5 and 9. Okay. The final way you could also organise this data is by splitting the stem into fifths. Okay. Now, when you're splitting it into fifths, basically you're going to have 5 of the same stem, okay, and each stem will have different numbers in it. So the first stem will have the 0s and 1s in it, in the leaf column. The second stem in the leaf column will have the 2s and 3s. In the next column we'd have the 4s and 5s, and then you'd have the 6s and 7s, and the 8s and 9s. Okay, so again, when I put all the numbers in, so all my 0s and 1s, all my 2s and 3s, all my 4s and 5s, all my 6s and 7s, all my 8s and 9s, I end up with a stem and leaf plot. And again, this one probably tells me a little bit more information, because now I can see that of this data, most of the data is in the first 2 stems, so in between 0 and 1 and 2 and 3, okay, where there's not so much down this end. So it is often useful to break the data up into halves and fifths when the data is really close together. I guess a little rule of thumb you could use is you probably want to have around about 5 stems in a stem and leaf plot. If you're having any less than 5 stems, you've got to sort of break it into halves or fifths so that you do have around about 5 stems at the minimum. Okay. Final thing I just want to say is I've called the stem and leaf plots here stem plots. But yeah, as I said before that, they will often be referred to as stem and leaf plots. So stem plots is just the shorter form of stem and leaf.